Okay, my friends, so this is going to be real quick, and I'm just going to use some web pages that have enough information for us to know about. The first measure that we're going to focus on is called skewness. This is, we've talked about the word skew in class before, and there is a measure for skewness, and the idea of this measure is I will definitely give you money. I promise, Jimmy, I always do. I just can't do it right now. I'm making a video. The idea of a skewness measure is it measures how much the curve leans to one side around the average or the median. So there's a couple quick pictures here of negative skew and positive skew. This is negative skew because the tail goes off to the negative side of the curve. Positive skew because it goes off to the positive side of the curve. Here's an example of, again, positive skew, negative skew, and symmetrical, non-skewed data. Now, these pictures are great. You know, this is a wonderful little image. The problem is that wonderful image doesn't actually represent real data. That represents kind of real data where you've got definitely some symmetry, but then you've got the reality of what's going on here. So skewness is a measure. I'm never going to ask you to actually calculate the measure because it ends up looking like this. And I don't want you messing around with that stuff. There's all kinds of, there's all kinds of mathematical ways to calculate skew. I am going to teach you in the quiz how to use Excel to calculate the skew. Okay, now that's great, but the only problem with skew is it only checks to make sure that the curve is a mirror image of itself. So one way for a curve to be a mirror image of itself is in a symmetrical distribution like this one. But there are also other distributions like what's called the uniform distribution. Here we go. This is a very extreme example, but a uniform distribution looks like this. I mean, this is definitely symmetric. That rectangle is definitely symmetric. Here's another good example of one right here. That's symmetric left to right, same size left and right. But it's not a bell curve like the normal distribution. So we need a measure that actually can identify whether we've got the correct tails. And that's another fun one called kurtosis. This is a good one, kurtosis. So I don't exactly know what the word means. And this website does kurtosis and skew. We already talked about skew. So kurtosis just measures, do you have a bell curve like this orange one here? Or is it too tall and skinny? Or is it too short and fat? So the idea is, how fat can the tails be? And how tall can the curve be? And still be considered a bell curve, if that makes sense. I know we call everything that looks like this in statistics a bell curve, but technically speaking, a bell curve has a certain proportion height to width. So again, these things have measures. There's the measure right there. It's a mess. It's a mess to calculate. And then again, we're going to use Excel to calculate these things. So, and more importantly, I don't even care about the equations. What I care about is if you have normal data, what values do these two measures, skew and kurtosis, take on? So let's take a look at that next.